class we have discussed about introduction in kinematics, then concept of rest and motion, then types of motion, then we studied one dimension, two dimension and three dimension. Today we are going to discuss about elementary concepts of vector algebra. In unit 1 we studied 7 fundamental quantities. What are they? Length, mass, time, temperature, electric current, amount of substance, and luminous intensity. These physical properties will have some, or these physical quantities will have some properties. What are the properties? One is scalar. The second one is vector. So what is scalar? It has only magnitude. It has only magnitude, then I can call it as scalar. If a physical quantity has only magnitude, I can call it as scalar. Vector means both magnitude and direction. Both magnitude and direction, then I can call it as that physical quantity as vector. Examples of scalar and vector. Length, mass, temperature, distance, speed. These are all examples for scalar. For vector, the examples are velocity, acceleration, torque, etc. These are all examples for vector. Now, I will give an example for scalar and vector. Now, your school is at a distance of 5 km from your house. Here, I used only one dimension, that is distance 5 km. This represents scalar. Suppose if I say your school is at a distance of 5 km from your house and it is located in the northeast direction. Here I used two dimensions. One is the length, that is the distance. The other one is the direction. That represents the vector quantity. Now we will go to magnitude of vectors. Next we go to magnitude of a vector. Now let us consider this is a vector and let it be a vector. The length of this vector will give the magnitude. The length of this vector will give the magnitude of a vector. Now I can write this a vector can be represented in the form of magnitude, means a modulus of a vector, that will represent the magnitude of a vector. Next we will go to types of vector. There are three types of vector. One is equal vector, The next one is unit vector. The third one is orthogonal vector. So there are three types. One is equal vector, unit vector, and orthogonal vectors. This unit vector is having a squares, a branch, and is collinear vector. This collinear vector is consists, one is parallel collinear vectors, the other one is anti-parallel collinear vectors. Now, what is equal vector? If I can go, that is equal vector. It must, if I take two vectors, A vector and B vector, if I take two vectors, it must have same quantity. It must have same quantity. Suppose if A vector is represents velocity, means B vector also must be velocity. So it must have same quantity. Next, A vector must be equal to B vector. That is, magnitude must be same. The third one is A vector and B vector must be in the same direction. Must be in the same direction. A vector and B vector must be in the same direction. Then we can call it as equal vectors. Clear? Now, let us take an example. This graph shows whether this is A vector, this one is B vector, whether they are equal, same quantity, yes, but see the magnitude, they are not same. So therefore A vector is not equal to B vector. Next example. Same magnitude, same quantity, equal in magnitude, and see the third rule, they are not in the same direction, they are in opposite direction. So these two vectors are also not equal. So that means A vector is not equal to B vector. Next, please another example. Now you see, this is of 5 unit, means this also 5 unit. Okay. Now whether they are equal, so here A vector is equal to B vector. These are all some examples for equal vectors. Next, we will go for collinear vectors. If two vectors lie on a same line, then I can call it as collinear vectors. For example, this is A vector and this one is B vector. Now you see, these two vectors lies on the same line, then I can call it as collinear vectors. So in collinear vectors, we are having parallel vectors. The other one is anti-parallel vectors. We have parallel vectors and anti-parallel vectors. So if two vectors, A vector and B vector, are in the same direction, it may be along the same line, or it may be what? Parallel. These two vectors may be on the same line or they may have parallel. Then I can call it as parallel collinear vector. And for this, the angle is 0 degree. The angle is 0 degree. For parallel, the angle is 0. So understood? But the two vectors must be in the same direction. In anti-parallel, if I take two vectors, they will be in the opposite direction. They will be in the opposite direction. Then I can call it as anti-parallel collinear vectors. Here also, the lines, the two vectors may be on the same line. The two vectors may be on the same line or parallel. The two vectors may be on the same line or parallel. Here the angle is 180. The angle is what? 180. This will give the anti-parallel collinear vectors. Next we will go to unit vector. Here unit vector means its magnitude as 1. Whose magnitude is 1, then we can call it as unit vector, and it is represented by cap. It is represented by cap. Now you see, now this is a vector, a vector. Whether I can call this one as a unit vector? No, because its magnitude is greater than 1. Understood? Now if I take a vector which is in the same direction of a vector and has magnitude 1, then I can say this vector as unit vector of a vector. I can call this vector as unit vector of what? A vector. So I can write a cap is equal to a vector divided by modulus of a vector. This is how to calculate the unit vector. So unit vector is equal to a vector divided by modulus of a vector. That is about unit vector. Next we will go for orthogonal vectors. Orthogonal means perpendicular, that is 90 degree. If two vectors are perpendicular to each other, then I can call it as orthogonal vectors. Let us consider this is A vector and this one is B vector. These two vectors are perpendicular, that is 90 degree, then I can call it as orthogonal vectors. Now you take this one. Three coordinates, that is x coordinate, y coordinate, z coordinate. They are mutually perpendicular to each other, that is 90 degree. So I can call this one as orthogonal vectors. This one here I cap, j cap, k cap. This I cap, j cap and k cap are the unit vectors for x axis, y axis and z axis. So all are perpendicular to each other. I can write the angle is 90 degree. This is called orthogonal vectors. Addition of vectors. So vector is nothing but having both magnitude and direction. Now, if I want to add two vectors, let us consider A vector and B vector. I want to add these two vectors. By ordinary algebra, we can't add these two vectors. There are two methods to add the two vectors. The one method is analytical method. Analytical method. The other one is geometrical method. That is geometrically method. What is analytical method? Suppose A vector is equal to 2i plus 3j plus 2k or 3k, and B vector is equal to 3i plus 2j plus 5k. Now I want to add these two vectors. So I will be getting what? 8k 5i plus 5j plus 8k vector. This method, what we can call it as analytical method. Now, what is geometrical method? Now, this one is A vector. This one is, I can write it like this. This one is A vector and this one is B vector. Now, I want to add these two vectors geometrically. So, by doing this, we should not change the direction and the magnitude must be same. We should not reduce the magnitude also. Then how I can add? So what we should do is, we must change the position. Just move like this and bring it in this form. That is, this one is A vector and this will be B vector. Now, this arrow mark means this will give tail, this will give head. So, tail, head, head. These two tails will make to join. So, if I add these two vectors, I will be getting a resultant vector R. I will get a resultant vector R. This is a way to find out the geometrical form. Next, there are two methods for addition. One is triangular law of addition method. The second one is parallelogram law of vectors. Now, we will discuss about triangular law of addition method. This one is a definition. In exam, they will ask in 2 mark question. If they ask in 5 mark question, you must write the definition along with the derivation. First, I will explain about definition, then we will go for the derivation part. Now, let us consider. Now, before going to the diagram, I will take a triangle. OA is one side, AB is another side, OB is a third side of the triangle. This OA and AB, if I take, these two are adjacent sides. If I add these two sides, then I will get the resultant, that will be the third side. Here, now we will go for the diagram. Let us consider OA is one vector, let it be A vector. Then AB is B vector. What will be the resultant? This OD will be the resultant vector that will be in the reverse form. Now I will come for the definition. This OA and AB must be in the same order. Must be in the same order. That is same order. And the resultant will be in the reverse form. And the resultant will be in the reverse order. See, OA, AB, and the resultant will be from OB, not from BO. That is OA, OAB, Suppose it becomes BO, then I can call it as same order. I can call it as same order. If this is OA, AB, if I come to OP, then I can call it as reverse order. So it should take it in the form of reverse order. So now you see the definition. If two vectors, that is A vector and B vector, are represented by two adjacent sides of a triangle taken in the same order, then the resultant is given by the third side of a triangle taken in the reverse order, that is OT. And the resultant will be equal to A vector plus B vector. Here. Now, I want to find out the magnitude and direction of the resultant vector. For calculating the magnitude and direction, just in mathematical form, we will extend this line. We extend OA, and from B, you draw a perpendicular line so that it will meet at a particular point, name it as N. Now you see a right angle triangle is coming. This ODN is a right angle triangle. From that, I can calculate the resultant vector, that is for magnitude as well as for direction. Now, these two sides, it makes an angle theta. Why I am using angle outside instead of keeping inside? That is, this is tail, this is head. This is tail, this one is head. So head and head, if head and head or tail and tail, if they means the angle will be inside. The angle will be inside. If there is head and tail means the angle must be outside. Clear? Next you will see magnitude of a resultant vector. Let OA vector is equal to A vector. AB vector is equal to B vector. And theta is the angle between AN and AB. Now, in right angle triangle OBN, in right angle triangle OBN, so in right angle triangle OBN, okay, according to Pythagoras theorem, I can write OB square equal to ON square plus BN square plus BN square. So OB square equal to ON, I can write it as OA plus AN. OA plus AN, the whole square plus BN square. So OB square is nothing but what? R square. OB square is nothing but R square. That is equal to OA, it is A, plus AN. Now I will calculate AN. For that, you take this triangle ABN. Now, in triangle ADN, cos theta is equal to adjacent side by hypotenuse. So cos theta is equal to, what is adjacent here? AN. Then hypotenuse is B. So AN is equal to B cos theta. AN is equal to B cos theta. So now see here, AN is equal to what? B cos theta whole square. Then plus, now I want to calculate Bn. So Bn, I want to calculate Bn. So sin theta is equal to what? Opposite by hypotenuse. So sin theta is equal to, what is opposite? Dn. By hypotenuse is D. So Dn is equal to D sin theta. Dn is equal to D sin theta. So I can write D sin theta whole square. I think it is clear. Now this one, A plus B whole square formula. A plus B whole square formula is what? A square plus B square plus 2AB. So I can write R square equal to A square, square is B square, square is cos theta, cos square theta plus 2AB. 2AB plus square is what? B square sin square theta. Here you see this B square, here B square common. So I can write R square equal to A square plus B square cos square theta plus sin square theta plus this value 2AB cos theta. So we know that sin square theta plus cos square theta equal to 1. So R square equal to A square plus B square, this will becomes 1 plus 2AB cos theta. So I need only the resultant. So R is equal to this 2. If it comes that side, it becomes square root. So A square plus B square plus 2AB cos theta. This is the magnitude of a resultant vector. This, or I can write it as what? A vector plus B vector modulus, that is equal to square root of A square plus B square plus 2AB cos theta. Here, now we will go for so next we will calculate the direction of the resultant vector. Direction of a resultant vector. Now we take this triangle O N B. This is R, this one is alpha, here it is A, and this one is A vector. Now, here alpha is the angle between ON and OD. Now, in triangle OBN, tan alpha is equal to what? Opposite by adjacent. So tan alpha is equal to what is opposite? BN. By what is adjacent? ON. So I can write tan alpha is equal to BN by ON. I can write as OA plus AN. OA plus AN. Okay. So tan alpha is equal to Bn. What is Bn? D sin theta divided by OA A plus AN B cos theta. So we need alpha. So alpha is equal to, bring this term this side. It becomes tan inverse of this term D sin theta divided by A plus B cos theta. This will give the direction of a resultant vector. Now you will see an example, that is 2.1. It is given in your textbook, page number 49. Two vectors A and B vector of magnitude 5 units and 7 units respectively, making an angle 60 degree. Now this is A vector of 5 units and this one is B vector of 7 units, and it makes an angle 60 degree. So what is given? Again can go, so OA is equal to 5 units, OB, or I can write A vector, then this is B vector equal to 7 units and theta is equal to 60 degree. Find the magnitude of the resultant vector. So they asked to find out the magnitude of the resultant vector, that is R. Then and its direction. So direction means alpha. So we know that according to law of triangular addition method, R is equal to square root of A square plus B square plus 2AB cos theta. So square root of A 5, so 5 square, B 7, so 7 square plus 2 into 5 into 7 into cos 60. 25, 7 sevens are 49, plus 2 into 5 into 7 into cos 60, 1 by 2. This 2 and 2 will be cancelled. So R is equal to 25 plus 49 plus 35. This will give so R is equal to square root of 109 units. Now we will go for direction. Alpha is equal to tan inverse of B sin theta divided by A plus B cos theta. So tan inverse of, what is the value of B? 7 into sin 60 by A 5 plus 7 into cos 60. So tan inverse of 7 into sin 60 root 3 by 2 by 5 plus 7 cos 60 1 by 2. So tan inverse of 7 root 3 by 2 divided by, take the LCM, so it becomes 10 plus 7 whole divided by 2. This 2 and 2 will be cancelled. So alpha is equal to tan inverse of 7 root 3 by 17. So that is equal to tan inverse of, you will get a value as 0. That is, if I simplify this and if I see that is tan inverse of 0.7, if I simplify this I will get 0.713. In log 2, in tangent side, if I find the value of this, I will be getting it 35 degree. I will be getting as 35 degree. So therefore alpha is equal to 35 degree.